Hello everyone, welcome to our presentation on tracking the storm, visualizing trends in US hurricanes and climate impact developed by our team Hurricoders. This project focuses on understanding the increasing frequency and intensity of hurricanes, their patterns and impacts using advanced data visualization techniques. Coming to the abstract and motivation, our motivation stems from the devastating impact of hurricanes such as Helene and Milton. We aim to identify patterns in frequency, intensity, and geographic distribution of hurricanes to improve preparedness and resilience strategies. Coming to the dataset and methodology, the dataset spans from 1851 to 2015, comprising over 49,000 entries and 22 variables. It includes unique identifiers for each hurricane, detailed temporal data, geospatial coordinates, and meteorological metrics such as maximum wind speeds and minimum pressure. We employed Python libraries like Matplotlib and Seaborn for visualizations. The dataset's strengths include its comprehensiveness and historical depth, but its complexity posed challenges in simplifying insights for broader audiences. And in this slide, you can see the existing works by NOAA's Historical Hurricane Tracks, the Washington Post Hurricane Paths Map, their strengths and limitations. And here we can see the summary of the visualization methods we used for our project. And coming to the temporal trends in hurricane activity, we can see the bar chart spanning 1851 to 2015 showing the number of hurricanes per year with a peak in 2005. And this spike correlates with the increased detection capabilities and warmer ocean temperatures during that period. And the line chart highlights an upward trend in maximum wind speeds, reflecting both stronger storms and advancements in measurement accuracy. This aligns with our findings from climate studies indicating a rise in storm intensity due to warmer sea surfaces. And in this slide, we can see the decadal analysis. Grouping data by decades reveals an upward trend in hurricane occurrences peaking in the 2000s. And however, recent decades show a slight decline, likely due to improved monitoring techniques and changes in climate dynamics. Coming to the seasonal patterns, here the visualizations highlight that most hurricanes occur between August and October, with September seeing the highest activity. Box plots illustrate variability in peak wind speeds during these months.
Here is the intensity trend visualization where we can see the categories 1 and 3 are stable over time, while categories 2 and 4 exhibit higher variability, reflecting changes in environmental factors. These trends help us understand which hurricane intensities are more predictable versus that are requiring closer monitoring. Moving on to geographical distribution, this visualization helps us in identifying the high risk areas. The heat map on the left highlights the hurricane hotspots, particularly in the Atlantic region, whereas the scatter plot on the right clusters the hurricane paths by region, showing us how geography influences storm trajectories. These visualizations identify high risk areas and guide us in regional preparedness efforts. Moving on to the next slide. Statistical relationship. This correlation matrix shows us a strong positive relationship between the year and minimum pressure, and a weak negative correlation between the year and maximum wind. This is also likely due to the improved data collection post 1940, whereas the pair plot highlights the variability in wind speed, pressure, emphasizing the complex dynamics of the storm intensities over time. Moving on to the next slide. This hurricane lifespan. The histogram reveals most hurricane lasts only up to 1 to 5 days, with sharp decline for the higher durations. This confirms that the hurricanes are mostly short-lived, and which is also crucial for optimizing the emergency response windows in these days. Moving to the next slide, the cumulative landfall graph shows a consistent rise in hurricane events over time, which reflects the improved tracking and potential increase of the storm activity over time. Moving on to the next slide. Talking about the directional patterns, the polar plot indicates the hurricane saw predominantly travel northeast, while the bar chart shows the northeast bound hurricanes have the highest wind speeds. These findings enhance evacuation planning and hazard management during that time. Moving on to the next slide, the pressure and wind relationship. The line chart shows a sharp rise in the recorded minimum pressure post 1940, which is also due to better measurements during this time period. While the wind speed trends remain stable, the highlight advancements in the data accuracy and the impact on the storm is very understandable.
The Kerry plot reveals a skewed distribution of hurricane wind speeds, with moderate storms being most common and extreme storms rare. Anomalies highlight the need for data validation, aligning with our goal to improve data accuracy and analyze intensity patterns. The time series analysis shows an upward trend in hurricane counts with clear seasonal cycles. These trends support our objective of understanding long-term patterns and peak activity periods for better disaster preparedness. Like every project has some challenges, even our project has some challenges, like multivariate datasets, geospatial density, historical data gaps, and visualization overload made analysis complex. To overcome these challenges, we took some adaptations like we filtered data subsets, enhanced geospatial maps with clustering, shifted to 2D visualizations for clarity, and standardized historical records. These steps directly contribute to achieving our objective by addressing data limitations and enabling more effective visualizations. Some of the insights we got from our project are a 30% increase in category 4 and 5 hurricanes over the past 40 years due to climate change. High activity along the Atlantic and Gulf coast with peak occurrences in late summer. Economic damages exceeding $1 trillion since 1980. These findings highlight the urgency of understanding hurricane dynamics, aligning with our aim to provide actionable knowledge for preparedness. Some of the future directions we want to propose to expand this study are including global hurricane data for comparative analysis, integrating climate variables like sea surface temperatures and atmospheric pressure, developing predictive models to improve early warning systems, enhancing interactive visualization for public awareness. These strategies aim to deepen our understanding and strengthen resilience against hurricanes, fulfilling our project objectives. Therefore, we want to conclude that hurricanes are becoming stronger and more frequent due to climate change, emphasizing the importance of preparedness and resilience. Our analysis provided critical insights into frequency, intensity, and geographic trends, offering a foundation for informed policy making and disaster planning. By employing data-driven techniques, we contribute to building community resilience and improving disaster response strategies, achieving the primary goals of our project. So these are some of the references we used while building our project. Thank you.